So now we're going to factor and solve polynomial equations, meaning, for the most part, something higher than quadratic, because we already did quadratic. The thing is that quadratic kind of forms the basis for most of this stuff. The new techniques are, in some case, like the number one thing I'm saying, that greatest common factor. Well, usually it's greatest common factor, like you take out a common factor of x, and then what's left is a quadratic in some way. We have two new formulas for sum and difference of cubes. We have grouping, which is a new technique, but actually it's something that you did before, but I'll show you where you did it. And then we do what they call a quadratic form, or in some books they call it quadratic type. But in a way, it's kind of bringing us back to what we did with quadratics. So those are the four things. So first, these are all greatest common factor. If you look at in each one of them, you're starting with a polynomial which is higher than a quadratic, but there's a greatest common factor of some exponent of the variable, some power of the variable. So in the first one, it's x to the third, but actually each term has got an x in it. So you factor it out, and now what's left inside parentheses is a quadratic. So you just use the same old methods that we did before, hopefully only using one step to go from x squared plus 2x minus 15 to x plus 5 times x minus 3. Right? Don't turn those into 5-step processes. Okay, look at the next one. It's a 5th degree polynomial. Right? Who would have thought we could factor a 5th degree polynomial? Well, if you notice, each term has got a y to the third in it. When you factor that out, you're left with a quadratic. In fact, you're left with a difference of squares. So you go ahead, first you take out the greatest common factor, then you do the difference of squares. And the last one, greatest common factor, looks like all those numbers are divisible by 4, and each term has at least 2 z's as factors. So take out 4z squared, and you're left with a perfect square trinomial, z squared minus 4z plus 4. Right, that's what they mean by greatest common factor plus. Actually, I think I made that up. Okay, so go ahead and try that one. What was the greatest common factor? X, that's wrong, equals blue, x times x squared minus 7x plus 10. Okay, now how does that factor? -5 and -2, right? That's a one step. Right? No reason to make that into a 5-step thing, because once you got those two numbers, you've got the answer. Right? If this were an equation, what would be the answers? If this was all set equal to 0, what would be the answer? You would be missing 1. And 0, don't forget 0. When you've got a factor of x, that means you've got a 0 of 0. Right? If it's not plus something or minus something. Everybody always remembers the 5 and the 2. But we never remember that 0. Yeah?
Wait, so if it was like not an x on the outside, but like say 5, would it still be 0?
No. 5 cannot equal 0. Right? The zero product property says when you multiply factors together and get a product of 0, then one of the factors must have been 0. Now, if you had 5 instead of x there, 5 is clearly not going to be the source of the 0, because it's 5. But when you have a variable, the variable could be 0. So you have to include that as a possibility, right? Yeah, because students do that all the time at this kind of stuff. You might have had 5 times x minus 5 times x minus 2, and somehow they'll get a solution out of that factor of 5, and there isn't. In fact, if it's a factor of 5, you could just divide it out, right? Doesn't matter. Okay. Then we get to the sum and difference of cubes, or what they call the sum and difference of 2 cubes. Usually on the SOL, there's like 2 or 3 questions that deal with this. And a lot of times you can solve them just by like pattern recognition. If you notice both of these formulas right here and here, the sum of cubes and the difference of cubes, it factors into a binomial times a trinomial, right? 2 terms times 3 terms. So if you get a multiple choice question that says, what is factor the sum of cubes, and one of the choices isn't a binomial times a trinomial, then you throw it out. It's got to be a binomial times a trinomial. And that can get you far. The next thing is that notice the binomial, if it's the sum of cubes, meaning a plus there, then the first factor, the binomial, is also a sum. Plus matches plus. And minus matches minus. So in a multiple choice format, if you can't remember the last one, the trinomial, but it doesn't have that part right, then of course it can't be the right answer. So you could be throwing out questions because they're not binomial times trinomial, or because they just don't have the signs in the right places. Okay, and then notice on the sum, right, those 2 match, and then the first operator inside the trinomial is the opposite sign, right? So it goes from plus to minus. And then for the difference, the minus matches the minus in the binomial, and then inside the trinomial, it's a plus. It's the opposite. So without doing like any other work at all, probably 1 out of the 3 questions you could get right just by matching those things up. Now, if you don't remember anything beyond the binomial, you can actually figure it out by doing long division, right? I mean, what if I go to this, I'll do the 64x to the third minus 1. Okay, I recognize that means 4x in parentheses cubed minus 1 cubed, and that means that the first factor should be 4x minus 1. Okay, that part I know. Okay, well then divide 64x to the third minus 1 by 4x minus 1. You'll get what the trinomial is. Remember, if I'm going to divide 64x to the third minus 1, it's missing two powers of x. So I would have to write it like this. 64 x to the third plus 0 x squared plus 0 x minus 1. And then I'm going to divide by 4x minus 1. Right? What do I multiply times 4x to get 64x to the third? No. 4 times 8 is not 64. 4 times what is 64? 16. Okay. Now I multiply 64x to the third. Then 16x squared times minus 1 is minus 16x squared. Subtract. 0 minus negative 16 plus 16. Okay, now what do I multiply times 4x to get 16x squared? 4x. So 4x times 4x is 16x squared. 4x times negative 1 is minus 4x. Subtract. 0 minus negative 4. 4x. Bring down the 1. And then plus 1. 1 times 4x minus 1. Remainder is 0, which it should be. Right? Because we know that 4x minus 1 is a factor. So that should mean when you divide, you get a remainder of 0. So there, I got that second polynomial here, which if you didn't remember it, I figured it out with long division. It's right there. Or you could just memorize the formulas because they're not given to you. Okay, so what number cubed is 64? 4. So this is x to the third plus 4 to the third, right? Which is x plus 4 times x squared minus 4x plus 4 squared, which is 16. So since it was a sum, I made my first factor, the binomial, is a sum, and then the inside, a minus. The last term is always a plus. Always, always, always. So they really don't have a lot of solving equation stuff in this unit, in this lesson right here. But if, for example, this had been an equation like equals 0, then what would you say are the zeros? Yeah, -4 comes from this one, right? Now, the trinomial, when you factor a sum or difference of cubes, is never factorable. So you have to use quadratic formula. And when you do, you always get imaginary solutions. So in terms of like x-intercepts, looking at the graph and seeing an x-intercept, the only one you would see is -4. These are going to be imaginary, so it's not going to be reflected by an x-intercept of the graph. And you can kind of prove why is it that you would always get, I mean, if you get a negative, if you get imaginary solutions, what does that tell you about the discriminant? It's negative. So you should try to prove to yourself, why is it the discriminant would always be negative in this situation? I mean, you can do it fairly easily. Okay. So I'm not even remembering. Do I have a you try? How about try to do the number 4? So what number cubed is 27? 3. So w to the third minus 3 to the third. So just, here, follow the formula exactly like it is. In our problem here, it looks like the a is w and the b is 3. Remember, the minus is part of the formula, right? It's not that the b is -3. The minus is in the formula. So we're going to say, since it's a difference, then the first factor is a difference, w minus 3, right? And then the first operator inside should be a plus. Right? Okay. So let me look at the number 3. You're looking at that saying, well, that doesn't look like a sum or a difference of cubes, but is there a greatest common factor? At the least there's a b squared, but then I would have to, is 16 a perfect cube? No. So I mean, if this is going to turn into the sum or difference of cubes, there might be another factor involved here. What's the greatest common factor here? It's not b to the b squared. It's 2b squared. I mean, you could see both 16 and 686 are even, so clearly you could divide out of 2. And when you divide 686 by 2, you get an odd number, 343. So actually, not only do you get that, if I divide out the 2b squared, if I divide that out, the first term becomes 8b to the third. And now I know I'm on the right track because 8 is a perfect cube. Right? What number cubed is 8? 2, right? So, and 686, 343. You got to at this point suspect that it's a perfect cube. And it is. What number cubed equals 343? How could you have your calculator give you a list of the perfect cubes? Right. Go to y equals and put x to the third y equals x to the third, and then look in the table of values. And just scroll down until you see it, and in fact, it's 7. When x equals 7, y equals 343. So that's 7 cubed. So 2b squared like that. And now we use the formula, right? In this case, the a is 2b and the b is 7 in this formula right there. So it'll be 2b squared times 2b plus 7 times 2b squared, which will be 4b squared, minus 2b times 7, which is minus 14b, plus 49. Okay, so try the number 2 right there. So what did you realize on this one? It's not a difference of cubes. What is it? It's a difference of squares, actually. What was the greatest common factor? 3y to the third. And when you take that out, you're left with y squared minus 25. And that's a difference of squares. So that was kind of a trick question. 3y to the third, and then how do I factor y squared minus 25? Y minus 5, y plus 5. Okay. Okay, now we get on to the next kind of, we already did the greatest common factor. We did the sum and difference of cubes, and now we're doing the grouping. So you do grouping when you have 4 terms. If there's 4 terms, sometimes grouping will work for you. And we've kind of done this before. Like, for example, if we had to factor a quadratic, like this one, 2x squared minus x minus 3, right? We would have to do that long process, right? We would say 2 times negative 3 is negative 6. What are the factors of negative 6 that add up to negative 1? Yeah, negative 3 and 2. So what did we do with that? We split up the middle term so that we had 4 terms. So then you group the first 2 and we group the last 2. Okay, well that's what we're going to try to do here, is group the first 2 and the last 2. Now, it doesn't always work. Most of the time it does not work. But if they say to factor a polynomial, a cubic, which means cubic means it could have 4 terms, the cubic, the quadratic, the linear, and the constant terms. Notice the pattern, 1x to the third minus 3x to the third, and then negative 16x plus 48. Each one of those, the second term of the 2 is like negative 3 times the one before. So that tells you it's going to work. If I just group this. Now, you got to be a little careful on this one because of the minus where it is. X to the third minus 3x squared minus, and now because of that minus in parentheses, what goes inside parentheses? I have to flip the sign on the 48. Okay. Now, greatest common factor factoring on each set of parentheses. What's the greatest common factor for the first set? Okay, what's left behind? Okay, what's the greatest common factor? 16. And what's left? X minus 3. So, because we have the same thing in parentheses, x minus 3, then everything's going to work out here. And that's what had to happen when we did this one too, right? It always had to be that when you take out the greatest common factor, we always said it has to be that you're left with the same thing inside parentheses. So we got the x minus 3. So this is going to be x squared minus 16 times x minus 3. Okay, but we're not done. Because x squared minus 16, what kind of factoring pattern? It's a difference of squares. You got to keep going, right? So what will it be? Okay, so grouping. So try to do that one. Okay, so there's that. Everybody get it? Everybody I saw had it perfectly right. Which leads us to probably the one that will cause you the most trouble is quadratic type or quadratic form. But this is something you're going to see a lot. I mean, not necessarily in this class, but like in the next class, and they assume that you've had it here. But you know, we already know that. I think we're getting pretty good at difference of squares, right? But you could get difference of squares that look like this. Sine squared x minus cosine squared x. Okay. You don't have to know much about sines and cosines to just see that's a difference of squares. So how do we think it factors? Sine x plus cosine x, sine x minus cosine x. This is, by the way, that's how you say when you square a trig function, you put the 2 in the middle there. It's like saying sine x parentheses squared. But we do the same thing with logarithms and exponentials and higher degree polynomials, and you do it all the time. And if you see the difference of squares for what it is, which is a pretty straightforward factoring pattern, then it doesn't cause you much trouble to have to factor something like that. So we're just doing it with higher degree polynomials today. Okay, so like something like this, when I'm looking at it, I'm thinking, okay, it's not a difference of squares, but I see a lot of squares in there. 625 is what number squared? No, 15 times 15 is 225. 25, right? 16 is a perfect square. G to the 4th, okay, that's not a perfect square, but because it's an even degree, that means I could write it like this. I could put in parentheses, I could make this 4g squared, right? And then square that. And then I'll have minus 25 squared. So even though it's not really a difference of squares, it could be factored like a difference of squares. So what is the next line going to look like? 4g squared plus 25, 4g squared minus 25. But we're not done, because now 4g squared minus 25, 4 and 25, they're perfect squares, right? So we can't factor 4g squared plus 25, right? We don't have a formula for the sum of squares. But this one is going to be 2g plus 5, 2g minus 5. Okay, so try to do the second one. This will be your you try. So how do we do? It's pretty similar to the other problem, right? Just follow the same kind of steps. Okay. Okay, now these are also going to be quadratic form. Let me do the one on the right. What is the greatest common factor for the terms on the right? 2p squared, right? So you take out a 2p squared, and what's left is p to the 6th, right? Because remember, when you multiply, you add exponents. So p squared times p to the 6th is p to the 8th. That makes sense. Okay, then the next term is p cubed, okay? And then the next one is 6. So that's clearly, inside parentheses, that's not a quadratic. But it could be written like a quadratic because you could see the pattern there, right? In the middle term, you've got p to the 3rd, and the p to the 6th is p to the 3rd squared. So actually, you could write it like it's a quadratic, like this. 2p squared times p to the 3rd squared, oops, plus 5p to the 3rd to the 1st plus 6. So if you recognize that much, then you can see that we're going to factor this in one step by saying, what are the factors of 6 that add up to 5? 2 and 3, right? So it's going to be plus 2 and plus 3. It's not going to be p plus 2 and p plus 3. It's going to be p to the 3rd plus 2, p to the 3rd plus 3. Okay, now, I mean, what would happen now if I FOIL that? Right, p to the 3rd plus 2 times p to the 3rd plus 3. The p to the 3rd times p to the 3rd gives me p to the 6th, right? That's what I need. Then I get p to the 3rd times 3 and 2 times p to the 3rd. There's the 5p to the 3rd. So you got to recognize the pattern. So try to do the one on the left. That's your you try. You take out the greatest common factor, and you see that pattern. And this is by far the most common you see. It's usually 4th power, then squared. In fact, for a time, that was like the only one that they would always call quadratic form. This book tends to show us some different possibilities there. Right, so right away when you see it, you can say, well, I'm going to factor this like I would a simple quadratic trinomial. What are the factors of 6 that add up to -5, -2, -3? It's not going to be t and t, because they got to multiply together to give you t to the 4th. It's t squared. Right, now if you FOILed it, t squared times t squared is t to the 4th. So now you got it. Okay. So we factor as a means to solve equations with zero product properties. So that's what we're going to do now. Got a couple more slides where we actually solve the equation. Okay, so if we're going to use zero product property, then we need everything set to 0. So I'll do the one on the left. If I want to have everything set to 0, then I need to subtract 18x to the 3rd, right? So 3x to the 3rd minus 18x to the, sorry, that was the 5th. 3x to the 5th minus 18x to the 3rd plus 15x equals 0. Okay, any greatest common factors? There's a 3x, so you take that out. We have x to the 4th minus 6x squared plus 5. Is that right? Yeah. Equals 0. And again, you should recognize that pattern for, okay, this is going to be a quadratic form. Right. What are the factors of 5 that add up to negative 6? Negative 5, negative 1. So we're going to write 3x times x squared minus 5 times x squared minus 1. Okay, any more factoring? Josiah? Yeah, the fact x squared minus 1, another difference of squares. So let's do that. So we get 3x times x squared minus 5 times x plus 1 times x minus 1 equals 0. Okay, so what are the zeros? 1, negative 1, close. Remember, you would have to say, you know, if this factor, x squared minus 5 equals 0, that means x squared equals 5. And then when you take the square root, you have to say plus or minus the square root of 5. Right? So plus or minus the square root of 5. Now we're missing one, 0. Right? Remember, when you have just x by itself, then 0 is the 0. So how many zeros did we have? 5, right? 1, negative 1, 0, and then plus or minus 5. So that's 5. So one of the things that we learn in the next lesson, you know, the fundamental theorem of algebra says that if you've got a 5th degree equation, that you should have 5 zeros in the complex number system, meaning they could be real or they could be imaginary, but there's going to be 5. So let's say if we forgot the plus or minus, then we only have 4 real zeros. Is it possible that that 5th zero could have been an imaginary zero? Remember, what did we learn about imaginary zeros when we were doing the discriminant? How many different numbers of imaginary zeros could you get? You could only get 2, right? You couldn't just get 1, because where does that imaginary, the I, come from? It comes from the square root, which is after a plus and minus. So you never get 1, you always get 2. So there would be no way to say you only have 4 real zeros here and that the 5th one is imaginary. So you had to find that last real zero. Right? Try to do the one on the right. Okay, so again, get it everything on one side set equal to 0. I mean, because when you're doing zero product property, it depends on that. And take out the greatest common factor. Now, you could have divided out the 2, right? But you can't divide out the x. The x is actually a source of one of our zeros. So, you can divide out a constant. I think this goes back to what Kaylee was asking before, right? The 2 here, I could divide from both sides. In the end, if I'm multiplying all this stuff together, the number 2 is not going to be the source of a 0. It's clearly never going to be 0. But the x could be 0. So don't divide that out. Nobody did that I was going around. Okay, last one. Got to have a word problem. So you are designing a marble basin that will hold a fountain for a city park. The basin's sides and bottom should be 1 foot thick. Its outer length should be twice its outer width and height. What should be the outer dimensions of the basin if it is to hold 36 cubic feet of water? Okay. So, I mean, this isn't the greatest picture, but I can't copy it from the book because we don't have access to it anymore. But again, so they said the outer dimensions, the length should be 2 times the width and the height. So if the width and the height are both x, the length is 2x. Okay, the walls of this thing are going to be 1 foot thick. So it's 1 foot on each side around. And you can't see it, but it's also saying that there's a bottom on it too, and that's also 1 foot. So inside here, that's the volume of water that's going to be there. It's inside. It goes down as far as, 1 foot from the bottom. So we want to come up with a volume of this rectangular area. How do you do the volume of a rectangular prism? Length times width times height, right? So, what we know is the inside volume is 36 cubic feet. So we need the inside length, not the 2x, that's the outside length. So what would be the inside length? What is this length right there? It's got to be 2x minus 2. Right? It's minus this little 1 foot right there and minus this little 1 foot right there. So 2x minus 2. Okay, what is going to be the width? The inner width, which is just right there. X minus 2. Get it? Okay. And then what is going to be the height?
X minus 1.
X minus 1, right? It doesn't have a 1 foot on top. It just got on the bottom. Okay, now, something that I'm noticing here now, we have to figure out when is this true. That first factor, I could take out a 2. And then if I do that, I'll be able to divide both sides by 2. So let's do that. 36 equals 2 times x minus 1 times x minus 2 times x minus 1. Divide both sides by 2. 18 equals x minus 1 times x minus 2 times x minus 1. Okay, we need to get it like everything on one side, 0 on the other, factored form. So what do we need to do next? You're going to have to multiply those 3 factors. Okay, well, we did that yesterday, 2 days ago. I'm going to pick the x minus 1 times x minus 1. Not that it's a lot easier, but it's a little easier. So I'll have x minus 2 times, right, that's a perfect square trinomial. X squared minus 2x plus 1. And that's all equal to 18. Okay, now I need to multiply the binomial times the trinomial. And because I don't want to make a grid and take up all this space, I'm just going to do it horizontally. Right, this will be x to the third minus 2x squared plus x negative 2x squared plus 4x and minus 2. So that is x to the third equals 18. That is x to the third minus 4x squared plus 1x plus 5x minus 2 equals 18. Okay, not quite there yet. What do I have to do? Subtract the 18. So I got 0 equals x to the third minus 4x squared plus 5x. Negative 2 minus 18? Negative 20. Okay, now can we factor that? What was the one method of factoring we did today that had 4 terms? Grouping, right? So does it look like grouping will work? Look at the pattern from the first term to the second term and from the third term to the fourth term. You know, each one is like negative 4 times the one to the left of it. So this is going to work, right? If I group it, 0 equals x to the third minus 4x squared and that'll be a plus in the middle. That's good. 5x minus 20. Okay, the greatest common factor of the first parentheses is x squared. Okay, and that'll leave us an x minus 4. Plus, what's the greatest common factor? 5 times x minus 4. So 0 equals x squared plus 5 times x minus 4. Okay, so now we've got to, what are the zeros? Yeah, you're going to get x equals 4 right there. Okay, now what are the zeros that come from x squared plus 5? Yeah, it's plus or minus the square root of negative 5, which means I. So we're going to get imaginary solutions, right? So if I make a little equation, right, x squared plus 5 equals 0, then x squared equals negative 5. And when I take the square root, I get imaginary, right? Which we're not interested in. In this real world problem, our answer is not going to be an imaginary number. So the answer is 4. So they said find the dimensions, the outer dimensions of this tank. You know, it must be that the width and the height are 4 and that the length is 8. And then with 1-foot walls, the volume of the inside is 36 cubic feet. Okay, that's it. That's a pretty good problem, you know, the way it works out. You end up getting the grouping, factoring, everything. So you should start on the work because it's got plenty of time.